So for learning target 5.2, it wanted me to take the scatter plot that I just did, draw a line of best fit, and then write the equation of the line. So here's the scatter plot that I did. I need to graph a line, and the line needs to be what I think is a good average line for this data. So while I can see that this seems like the trend of the data is doing this, I wouldn't put my line down here because then all of my data is above the line. So I'm looking and I'm thinking kind of the slope of the line should be something like this to represent those points. And I'm going to put my ruler, if I were doing this with a ruler, but for me I'm just going to move this to where it has the basic slope, and I may have to move it a little bit of the line. But it looks like a fairly average line for the data. I've got points above the line, points below the line, and I am going to extend this line so that it crosses the y-axis, because that's going to be something like an eyeball and see if my answer seems reasonable. This to me seems like a fairly good line for this data. Now, I either need to have drawn this line through two of my data points or through two intersecting points of the grid like this. So actually, I'm going to use this point, even though it's not a data point, because I can tell that that's exactly 35 for the x and 65 for the y. So that's going to be one of my points. And then I keep looking, and you know this point right here, this intersecting point, which is 70 and 80, I'm going to use that one too. So I'm either using 2 points on the grid, like right there, where I can tell exactly what that is, or if I'm using one of the points of my data, I can go back to my data table to find what the coordinates of that point were. This one I'm guessing, and I'm not going to look back at the data table, is something like 63 or 64 for the x and 75 for the y. But I'm going to use 35, 65 and 70, 80 as my 2 points. So 35, 65 for one point and 70, 80 for the other point. Wants me to write the equation of the line. Well, the first thing I need in a y equals mx plus b kind of an equation, I need eventually to find the slope, which is m, and I need to find the y-intercept, which is b. I am not allowed to just eyeball the y-intercept off of my graph. It looks like it's pretty close to 50, but I don't know that it's exactly 50. It might be 50 and an eighth, or 49 and 3/4. And since 0, 50 was not one of the points in my data, I cannot say that this thing crosses at 50. And even if 0, 50 was one of the points in my data, unless I use it as one of the points that's on my line and I'm using it as my calculation, it may not actually be on the real line of fit. So I actually need to calculate this. Well, slope is rise over run. Y is rise, so I have x's before y's. So I'm going to find the change in my y's, 65 minus 80, over the change in my x's, 35 minus 70, because y's rise, x's run across. This gives me negative 15 over negative 35. And when I reduce that, 5 goes into both of those, and negative divided by negative is a positive. I end up with positive 3/7 for my slope. Now, we're going to use a decimal approximation in another answer in just a little while, but not right here. So my equation is y equals 3/7. Notice that horizontal fraction bar with the x out to the side of the fraction bar. I need to find my y-intercept there. So I'm going to take one of my points. I really think that 70, 80 looks like the easiest one to use. And I'm going to say, well, if y equals mx plus b, the y value in that point is 80. The slope I just found was 3/7. The x value is 70. And the thing I'm trying to find is b, which is the y-intercept. Now, depending on the points I pick, I may end up with nasty fractions in here, and then I just deal with mixed numbers, and it's okay. But in this case, 3/7 times 70 is 30 plus b. Now when I subtract 30 from both sides, it turns that out that for this line, it really did cross the y-axis at exactly positive 50. Again, I needed to show the work for that though, because it may not have actually crossed at exactly 50. It may have crossed at 50 and 2/7 or 49 and 8/9. I have to show the work to show that. So my final equation, y equals 3/7 x plus 50, is the equation of the line I chose. Now, you may have chosen two slightly different points. What I was looking for, again, was this average line, two good points on the line, which, again, you may have ended up with fractional values, more fractional values in your equation. That's okay. You should have found, though, that your y-intercept was close to 50, probably somewhere between 48 and 52, depending on the points that you picked. And your slope is close to 3/7. And just to look at that, 3/7, if you turn it into a decimal, is 0.42857. So I'm not going to use that right now, but I will use that in just a minute. So 3/7 is roughly equivalent to 0.43 rounded to 2 decimal places. I don't want that rounded answer here, but we're going to use that when we talk about only target 5.3.